Hello.
Hi.
Let me pull the chat up. All right, it's 12 o'clock. Oh, shoot. Uh, there we go. Okay. Okay, I'm sorry. I'm getting things squared away right now. Thought I had them done or earlier, but evidently I don't. Yeah, let me pull the Zoom back up. There we go. All right, we're missing 5 people. So I'll give them a few more minutes. While we're waiting, please pull up the chat window and put your first name and last name in there as it shows up in ACES. No nicknames. That way I can, that's how I take attendance. Every day you sign into chat as soon as you show up to class. It's fine.
Wait, Adrian, where are you going? I don't think the homework.
How about now?
Yes, we can hear you now.
All right. Okay. Helps if I hit the right settings. Okay. Yeah. with Zoom, if I change the security program I have on my laptop, whenever I change my settings. All right. Oh, my camera, it lets me know who's using what program is using my cameras. And then a little green rectangle shows up at the top of my screen, and I click on the right side of it, and a little drop down menu comes, and the very first item on it is to hide the notification, which is what I click. So it's out of my way, because otherwise it's covering up some of the Zoom stuff. But the second item there is block application from using the camera. Well, I had evidently hit that during a conference a couple of weeks ago, a Zoom conference I was in. And so all I was showing was a blank screen. It was just black where my camera is. And it took me about a week to find the setting to undo so my camera shows up. So that was no fun. All right, if you haven't not already done so, go ahead and put your name in chat. First name, last name, or how your name shows up in ACES. So if you have 3 names that show up in ACES, please use all 3 names. I have one class that have 2 or more people with the same name, so first name and last name is helpful. Have some people have the same name, just they're spelt a little differently, like an I instead of an E or something like that, or 2 N's instead of 1. I worked with a man at Southside School District whose his last name was Villarreal with 1 R. The traditional way of writing it was with 2 R's, but someone in his family a couple of generations back decided 1 R was good enough. Okay, we've got almost everybody here. We're missing 2 people. 1 second. Haven't gone anywhere. I'm just. Oh, I have to do something real quick. Okay. Yeah, I'm supposed to have this on since I'm on campus, but there's nobody in the classroom with me. I'm not going to do that. I'll probably get fussed at if somebody walks by the room and sees me, but I'll deal with that when that happens. My name's Thomas Reed. I am your instructor for college algebra pre-calculus track. What that means is that everything due here is geared towards calculus, towards pre-calculus and calculus, with the impression or the what do you call it? Expectation that you're going to go into some higher mathematics, or going into engineering or some science or some of the sciences that require pre-calculus or calculus. So the other I'm a bit scattered this morning. Yeah, I had I've had a week's worth of problems, and it's only Monday. I got to school a little late. Yeah, I'm zooming from school because I'm going to end up using the computer here, and once they open up campus, if they open up campus this semester, I have 3 classes that are hybrid class. Half of the class is in the classroom and the other half is through Zoom. And so they call those hybrid classes. Not hybrid, dual modality. Hybrid class is something totally different. Hybrid class is where you do part of it in person and part of it online. The dual modality is half of the class is in the classroom, the other half of the class is remote at the same time. So I have an 8 o'clock class that's set up that way. And then I have a 10 o'clock college algebra class like this one, and then this one at 12. And then on Tuesday, Thursday, I have 2 different classes. I have a pre-cal and a 13-14 college algebra, which they call it a terminal math class because any other math you need to take is not built upon that class. You might need 2 math classes, but it's called terminal because it's a dead end as far as what you're taking after it. This doesn't apply to that class. So you might need college algebra and intro to stats or the liberal arts mathematics or something like that. But those are typically called terminal classes, courses. Anyway. So I got here late this morning and my key wasn't working and I couldn't get doors open and I couldn't remember the key code for my fob, and it's just, anyway, I finally got in the room, and the room I was supposed to go into, it was empty. I mean, a big empty. I mean, no desks, no tables, no podium, just an empty room. I don't even think they put in they've got 2 microphones up here and a new camera up there so you could do the dual modality classes that way. And so I went down to another classroom I'm assigned to. This classroom I'm in is actually one of the dual modalities, but it's a Tuesday, Thursday class. Anyway, oh, I'm sorry, I just noticed something here. Okay. So I finally got it going. I walked in the class about 5 minutes late. It took me another 5-10 minutes to set everything up. And then it was about 40-45 minutes into the class, my laptop died. In the process of getting everything set up, I forgot to plug in my computer. And so I came back online, and that was fine. And so my next class started, and about, I guess, 40 minutes into class, San Jacinto Hall lost electricity. So I lost my connection to the Zoom class because everything died. And yeah, but it came back on within a minute or two. So, I've been having a host of problems all day today. Hopefully nothing like that happens today. I mean, in this class. But anyway, now back to my opening day routine. My name is Thomas Reed. I'll be your instructor for this semester for this course. My job here is to help you understand this material well enough that that you can move on, that you can go into the pre-calculus and the calculus. My whole deal here is to use what I know about this course and the pre-calculus course and the calculus course to help you understand what's important to carry through. I'm here to help you understand the mathematics, not beat you up with the mathematics. I know that a lot of people have that experience with the math classes they've had in the past, is that their instructor has not been too kind as far as help is concerned. My wife, I use my wife as an example here. She's probably one of the smartest people I've ever met. And she thinks I do the devil's work. Before I go on, I like to see faces. So I like y'all to have your cameras on. The reason being, thank you. The reason being so I can see visual clues that you're catching what I'm saying. So if I ask a yes or no question, I can see heads nodding, or the sign language yes or the no, or whatever, that you're not getting it. And it's just much easier for me to deliver when I have faces to look at. And I'm going to subject you to my ugly mug. I need to see your pretty face. Unfortunately, I cannot require you to have your camera on, but it helps me in my instruction to have a full class up, not just a few of y'all. So I may remind y'all to go ahead and turn your camera on. I know I've had people in the past that have had issues, but we've discussed this through emails and during private Zoom sessions about what's going on. So if you have an issue with having your camera on during class time, please email me and we'll discuss it. Okay. Oh, my wife and mathematics. She probably had the worst example of math teachers throughout her public school education. She was taking algebra. I don't know if it was algebra 1 or 2, but she went home and tried to do the homework and couldn't get it going. Went over her notes, went over the textbook, did it several times, rereading her notes, rereading the textbook, trying to do the problems. And the next day she went to the teacher and said, explained to him what was going on. And he said, "So you read the textbook?" And she said, "Yes." And so he picked up his textbook and proceeded to read the section to her. That was how he explained things. And it's not surprising to me why she thinks I do the devil's work. And so she absolutely hates math. And that's just one reason why. And there's other reasons why, but I understand people having poor, bad examples for mathematics and why people are have trouble with mathematics. Now, I've been teaching a long time. this is my 31st year of teaching, I think. I've taught high school and middle school for 19 years. I did 2 years in a middle school, Mark Twain in San Antonio School District. I can honestly say I've done my time in hell. And, but for most of those 19 years, I taught freshmen on up to seniors. I taught everything from pre-algebra to calculus. I even taught physics 1 year. That year of high school physics, that taught me that I should never teach physics again. But they desperately needed a physics teacher, and I was the only one who could fit it into his schedule, and was stupid enough to say, okay, I'll teach it. But that was in Poteet. So I've taught in Poteet, I've taught in Pearsall, I've taught in at East Central, and I taught at my last public school was Southside. I taught there 5 years, which was 4 years too long. Had a change of principles, and it got bad from there. I taught in their credit recovery program, and the expectations of me changed every year, and it just got worse and worse. And so I decided to run away and teach college, which has been a blessing. I love teaching math. Anyway, I'm here to help you. That's what I'm here for. My primary job is to put the material up and present it in a way that you can best understand. If I'm failing to help meet your expectations of understanding what's going on, then it's up to you to let me know I'm missing the mark here. I'm not understanding that point, Mr. Reed. Can you go over it again? Or send me an email, or go ahead and interrupt me. The best way to interrupt me is not with the chat, but unmute yourself and say, Mr. Reed, I'm not catching this. Can you go over it again? And I'll go over it again, and then I'll try and cover it differently. That's what I do. If I have to go back over something, I usually don't do it the same way. I usually take a different approach to it, because my original way of explaining it isn't working for you. So maybe I need to do a different way. I understand that my way of seeing things may conflict with your way of seeing things, and so it interrupts how you understand what I'm trying to tell you. And that's why I want y'all to ask me questions, ask each other questions. I'm really big into having a group, a study group. When I went back to UTSA to pick up on my math hours, I was a late bloomer. My first time through college, I just barely got through it. But when I went back with a purpose, and I had a group while I was there. And I did 5 to 10 points better per class because of the group I had than if I didn't. I went from being an ABC student to an AB student. So that is significant. And I can't press enough on you the significance of having a study group, especially in mathematics, because mathematics is not a spectator sport. The only way you learn math is to do math. So I can talk myself blue going over the procedures and the algorithms and the definitions and the how-tos and why-tos. But unless you get down and start doing the math, that means doing the homework, you're not going to learn it. The only way I learned the math is by doing the homework and asking questions, not just doing the homework, but I'm not understanding how come my answer is different. How come I'm not getting it right? And so that's when I would start asking questions. I'd ask of my group, and then the last thing I would do is go talk to the professor, although the professor had totally had their doors open for me. Yeah, when I was at UTSA, all my professors were male. That wasn't by design, that was just how it happened. But yeah, I'm kind of fuzzy headed right now. I'm sorry. It's been a it's been an interesting morning for me. Hang on a second. Yeah, I've got an 8 o'clock, a 10 o'clock, and a 12 o'clock. And so this is my third class of the day. This is my second time to have pre-calculus. College algebra. So I have a pre-calculus, a college algebra, just like this one, and then this one. So groups are important, and along those lines, to help with facilitated groups, it's much easier to get groups going if you are physically in the same space. So with the remote classes, obviously we're not in the same space. So what I've planned on doing, and I'm going to share my screen with you, is over here discussions. There's no discussions up here yet, but once I'm going to open up a discussion window here for y'all to ask questions, to make comments, to discuss things with each other and with me. And if you have a group of people that you want your own discussion window in here, then let me know, and I'll set up a discussion window that has y'all's name on it, the group name on it. I had a class, a person in one of my classes actually a year and a half ago in the spring. As soon as mentioned about getting groups, he immediately got into the chat and started setting up an Instagram chat for groups. So he got about 4 or 5 people in his group, and then helped someone else set up their group. And so however you want to do this is fine with me. And if there's anything I can do to help, please let me know. So groups are important. They help you because it's that give and take. It's that, all right, you explained it to me, now let me explain it to you, and let's see how I'm doing here. Or I'm explaining something to you, and so I'm getting a better understanding of what it is. And that's one reason why I get good at math, is because I'm doing math all the time and explaining it in all different kinds of ways. So it's important. Okay. Since I'm here, let me go down to the course syllabus. I just changed the syllabus right before class started. So if you had the other syllabus, because it was for a different professor, because last week, was it last week? Yes, it was last week. I got this class. So I was given the opportunity to get this class and drop a class, because I have 5 classes right now, 3 on Monday, Wednesday, and 2 on Tuesday, Thursday. But I was given the opportunity to have 4 classes on Monday, Wednesday, which means after this class, I will add another class at 2 o'clock. But I would only had 1 class on Tuesday, Thursday. Or I could have dropped my afternoon class on Monday, Wednesday, and just keep my 2 classes on Tuesday, Thursday. The reason they originally would have had me do 4 classes and then on Monday, Wednesday, and then one class on Tuesday, Thursday is because my afternoon class on Tuesday, Thursday did not have enough people in it to make. It had low enrollment. It has 13 or 14 people in there, but that's not enough for it to make. Well, the dean lead said, go ahead. If he wants that class, go ahead and let him keep that class, and we'll drop the afternoon on Monday, Wednesday. And so that's what I decided to do. Because the way I'm feeling right now, I don't think I could do another class without a break. So, especially with the morning I've had. But anyway, as just today, hopefully it'll be okay. So what I have here is ways you can get a hold of me. I'm supposed to have office space in San Jacinto, but my key doesn't work to that door anymore. I don't know why. And so, and it's an adjunct office. And this phone number, it's a Google Voice number. It rings my phone number. So if I don't answer, please leave a voice message. But I prefer that you text. That way, I'll get it right away. You can email me. This is the email address, the ACES address. I ask y'all to email me through ACES because it will let my phone know that I got an email. I can't read the email, but I'll know who sent it and at least have the subject line. The reason I prefer that over Canvas is the Canvas email is because of how quickly I get notified. For Canvas, I have to log on into Canvas, and so I don't do that as often as check my phone. My phone will buzz at me or whatever that I got an email. Okay, this is the textbook, and we do it through MyLab. I'm having issues with they changed the way we access MyLab and how we put it into our classes, and so that's I'm still trying to figure all that out. It's supposed to be easier than what I'm making it, so I don't know what the devil is going on, but I'm gonna this afternoon and tomorrow I'm gonna be working real hard at getting that up and going. Because y'all need to be able to get in there and start doing your work right away. Yeah, access is online. You already paid for this. You already paid for the book and MyLab. The book is accessible through MyLab. So you can probably, I think you can download a PDF file of each chapter. It's a long and drawn out process, but you can do that if you want to. Okay. The department requires a graphing calculator. I do not. All you need is a scientific calculator. The TI-30A, there's many, the basic model is like $10 at Walmart. Who is it? Casio has one that's similar. It's about the same price. The TI version comes in different versions. The most basic model is like I said, $10, and that's the one I have at home. And then they have them that go up and get fancier. I think the most expensive one of the TI-30s is like $35. I don't see a need of spending that kind of money after one. Or you could go to the dollar store or I can't remember which one it was. A dollar store? Yeah, it was a dollar store. I found these in, and it's a little scientific calculator. They cost $1. It's cheaper to buy a new one than to replace the batteries in the old one. So it's a cheap little calculator. It does great things. The only problem is that it's $1. It's a calculator you bought for $1. So things could go wrong on it. I had I still do. I have a bunch of them that I would bring to classroom, and I had a student using one right in the middle of a test. The plus button quit working, or the 3 button quit working. And fortunately, I had enough calculators there that they just switched it out. I threw that one away. So that's the problem with a calculator that's only worth $1, is that you get a calculator that's worth only $1. Things and break or wear out quicker than you anticipate. But a graphing calculator is not required. I don't require it. The department does, so I have to put that there. A scientific calculator, I don't do any of the other graphing things on the calculator. I know there are people who like to do that, play with the graphing, but the graphing you do in this class, you have to do on pencil on paper, and I need to see the calculations you do to hand in and all like that. So, and there's the part on polynomial functions, there's graphing with that, and with the rational functions, there's graphing with that. And so those have to be done on graph paper. Okay. This is just a brief description of the class, and these are the general outcomes that we have to meet in this course. Okay. This, oh man, I thought this is not me. This right here, evaluations here, this is not from me. This is from the person who originally had this course. So I'm gonna have to, I thought I fixed all this, but I didn't. Well, I just imported the new stuff, and that this is part of it. Requirements for the course. You were expected to attend class the first week of class. First, these expectations, yeah, you miss one or more, then it's reason for withdrawal from the course. So you have to sign into my math lab, but well, these two restrictions here deal with my lab, and so those are out the window. Grounds for withdrawal from the class is being 5 or more assignments behind in your homework assignments. We'll have a discussion if that happens, and I'll send you an email and we'll talk about it. And it's not, boy, you're 5 behind, and so I'm going to drop you. No, you're 5 behind. We're going to have a discussion about what's going on, and do you need to drop, or can you get caught up? Most people can get caught up, so that's not a problem. Attendance missing 6 or more days of class. If you miss 6 days of class, that means you missed 3 weeks worth of class. A lot of professors just say 4 class periods because that's 2 weeks. At 4 absences, in the past, I've sent out emails asking what's going on. Are you going to be able to complete this class? But by that point, those people have usually already been in communication with me. So I don't immediately just drop you for whatever reason. Although if you've quit coming and you don't respond to me, then yeah, I'm going to drop you. Now for the grade for this class, you have 3 in-class exams, and the average of those is worth 60%. the quizzes and other assignments. And quizzes can be announced or unannounced. And if you're here for the quiz and it's an unannounced quiz, well, you were absent. That's on you. And then a comprehensive final. That means everything from today till the last day of class. That's when you will be required, or that potentially would be on the test. Generally speaking, if it wasn't on an exam, it won't be on the final. There are a few exceptions to that rule, but generally speaking, that's how I do it. The grades for the course is a standard grading scale for most institutions. There are others that don't always do that. The homework is assigned through MyLab. Students are responsible for keeping current with homework. Students are expected to ask questions if they're having issues with assignments. All right. If you're having issues with the homework, then the time to talk about it is then, not when the exam comes up. That's why there's an ask the instructor button. That's why there's show me an example. That's why there's different options there to help you learn and understand what's going on there. Okay. And that's what groups are for, to help you with homework. I had people who that's all they did is they did homework together, which is fine. That's perfectly fine as long as everybody is learning how to do the problems, not just, well, I'm doing the homework, here's all the answers, that kind of deal. And I don't want that. What I want is people understanding how to do it. So when the test comes around, there's no issue. And here's how I like to have reviews for the exams. Generally speaking, if it's not on the review, you won't see it in the exam. Every now and again, there's an exception to that rule, but by and large, if you don't see it on my review, then you won't see it on the exam. I try and post a review document before the review class, and the review class is a class period before an exam. I typically like my exams either on the Wednesday or Thursday, and so Monday or Tuesday will be the review. And so by the weekend, I like to get the review up, and I expect you to at least have looked at all the problems, if not worked all the problems before the review. Because how I like to conduct my review is, what are your questions? Some people ask me detailed questions about the homework, about the review, because they had issues with one problem or a couple of problems. So that's how I like to do that. And so, yeah. And so the average of these three conduct your exam average grade. Now, here's how I and other professors do this as well. The final exam can replace your lowest test grade for your average. Now, I have a friend at SAC that he only does it for up to an 80. So if all your exams are an 80 or above, he doesn't use the final. But if one of these is below an 80, he replaces that degree, that grade up to an 80. I mean, with an 80. So if you made a 69 on the first exam and you made us an 85 on the final, then that 69 becomes an 80. Okay. I haven't been doing it that way. I said, whatever, you know, whatever grade you make on this one, I'll replace that grade with. And that's what I've been doing, whether it was below an 80 or not. So you have all 90s except for one grade, and you're on your final, you made a 100 or an A. Then I'll replace them all with I'll replace that lowest one with the A. So that's usually how I've been doing it. In general, there'll be no makeups for missed exams or quizzes. Missing one or two, I mean, 2 or more exams is grounds for withdrawal from the course. That means if you miss, I had one person miss exam 1 and 2. So that means he got zeros for those 2 grades, but his last 2 grades were high enough that he still passed the course with a C. Actually, it was a high C because that was a 0 with 2 A's being averaged, which averaged kind of low. And then the final, as well as the was it this other 10% helped the. So this 40% overcame this failing or near failing grade. So he passed the class, but that was a rare event. Most people who miss 2 exams don't do well. So don't miss class. Don't miss exams. All electronic devices, books, notes are to be kept secure in backpacks or purses during all quizzes, tests, and exams. Purses and backpacks will be stowed under desk during all quizzes and exams. That means on your desktop, all I see is paper and pencil and calculator. For remote sections, these items are to be absent from your work area. So all you have in front of you to work with is the paper and paper to write on and a calculator. And I know it's hard for me to monitor that through Zoom. I understand that. I've had some serious cheating happen last semester. But I couldn't prove it because I couldn't see it because of the limitations of the Zoom. But there's and I didn't address this before that particular exam. So the other exams, I said if I suspect cheating going on, and so there had to be cheating going on because they had these questions word for word, number for number, expression for expression, exactly the same. Even the mess ups, where one person turned a plus sign to a T or an X, turned it sideways, and so it became a T. Just all these little mistakes that happened that I could see on this paper. Yeah, I could see how this is a copy of that paper. So I would address those problem by problem, person by person, saying that you and 2 other people have the exact same answer responses, the exact same work. So I'm calling foul here. Prove to me otherwise. And so, yeah. And that may be simply as enough as, all right, here I'm going to do the work right here and show me on camera. So, but yeah, It's usually in my lower classes that's an issue, and in my 14 and higher, there usually isn't that issue. There, attendance is taken, daily attendance is taken, it's not used as a grade, but aids in assessing grades. So if you're here every day and you're struggling and you need that extra point or two to boost you up to the next level, I'm more inclined to give it to you than if you've been had a score of absences, but you're still got a passing grade, but I can't see boosting your points anymore because you haven't been to class. So, yeah. Attendance will be taken sign-in sheet. Well, that's for what do you call it? Face-to-face. So in my dual modality classes, they'll have a sign-in sheet where y'all, the portion of my classes that are remote, have to sign in chat. You type your name in, first name, last name. And yeah. Oh, if you do not sign in, you're considered absent. Excessive absences are ground for withdrawal from the class as previously stated. I do record all my Zoom meetings and I post them in YouTube. There'll be a channel, and I haven't created the channel yet, and I will post the videos there. And you will have the opportunity to view them again if you need to. If you're absent, then you will have the opportunity to see what we discussed that day. This does not replace attending class. If you're absent, you're absent. Viewing the video does not take care of that absence. There's a huge difference between being able to have a one-on-one conversation or interaction with the class versus watching it on video and sending out emails. So the rest of this is boilerplate. It's on every syllabus. Yeah, early alert. There's two early alert. No, there's an early alert which happens like after the census date, I think. And then there's a midterm report, not a midterm exam grade, but a midterm report. My midterm report is based on the first exam grade and how much you're doing in MyLab. And the early alert is basically, are you in danger of failing based on what's going on here? And so if I think you're on the cusp, I'll put you on there. If your grade is like you made a high D or something like that, and your homeworks, you're doing all your homeworks, I'll put you on there only because you might need the extra help. And that's just one way of saying, okay, you need to be going to a tutor, you need to be contacting your professor, you need to, there are things you need to do to help you boost your understanding and boost your grade. Yeah, PAC has wonderful tutors, and they have great availability where you can get in and go to get your tutoring done. Let me go to student view here. All right. The order of things over here will be different. This will change here because I need to go in there and see what they've done. I may end up keeping some of their stuff, but since I don't live in that person's head, I don't know what they were doing here. Under files, I don't have anything in there yet. I don't think he put any, yeah. But in here is where I will post the reviews for the exams. I'll post any handouts I have for y'all. When we're doing graphing, I'll post some graph paper in there that you can either print up or whatever. So, and then I don't have any. Yeah, I need to totally. I've only had this course for less than a week, so I mean access to it for less than a week. So I haven't gotten in here and changed everything around to my liking. Okay. So, y'all have any questions for me right now? Let's stop this share. I got my work cut out for me this semester as far as getting things squared away. Okay. Well, in that case, let me see. There it is. In MyLab, you will have MyLab starts on chapter 1. I do not start with chapter 1. I start with chapter 2. And there are reasons for that. Yeah, I'm setting up my screens here so I still have y'all on I have 2 screens and have y'all on one and what y'all are seeing on the other. So this is the camera. And let me see, is it gonna read it? Yeah, do it this way. Here we go. So I'm gonna go ahead and start. If y'all don't have any questions for me, let me open up the chat because it closes the chat on me when I open up the when I do a screen share. And this on my computer, there's a lot of glare in here, so I can't see what I'm writing. So we're going to start with relations. All right. I had gotten a bunch of these dry erase markers and I could not find them when I left the house. And I did not have time to go get any more. And this is the only one they have in this classroom.
Hey, sir.
Yeah,
Do we have to take notes of this?
yeah,
All right.
because we're starting the class now as far as covering new material. And this is supposed to be working and it's not. Why isn't it working? Here we go. All right. Section 2.1 is where we're starting. There's some things from chapter 1 that is in my lab. If you have any issues with any of those concepts there, bring them up in class and I'll discuss them in class for everybody. Okay. Functions. We're going to describe what a relation is and determine whether, how to determine if a relation is a function. And then what makes a function, what doesn't. We go through some discussions of functions. Remembering that a function is a relation. So what's true of a relation will be true of a function. But not everything true of all relations is true of functions, because a function is like, here I have the set of relations here. If I did a Venn diagram, this would be relations. And inside this set is a subset of functions. So if it's a relation, if it's a function, it is a relation. So whatever's true of relations is true of functions. But because the definition of a function restricts which relations are in this circle, so what's true of a function is not true of all relations. It's only true of certain relations. And then functions are divided into, you have all different kinds of functions in here. Some of them overlap. So we have that. So most of mathematics deals with functions. Now in pre-calculus, we talk about conics, and in conics, we talk about the circle, and we talk about hyperbolas, and we talk about ellipses, which aren't functions. They're a relation. So we do talk about relations in higher mathematics, just a lot of the emphasis is on functions. It's all about outputs. Dealing with an X, that's going to give us a certain output. We'll get to that in a moment. All right, so definition of a relation. All right, well, I didn't go over this whole thing. And then and we're going to talk about function notation. Function notation is just basically giving a function a name. And then evaluating a function. You've been doing this since you were taught math. It's like putting a different number in place of the expression. I remember my kids, when they're in elementary school, they go blank plus 3 equals 9. What goes here? You know, that sort of thing. And that's or let's change what we're putting in here. So we're going to change what goes here. Well, that's what they're talking about there. Putting a different number in for the variable. And then we're going to talk about the difference quotient of a function. The difference quotient has more meaning to it once you get to calculus. Now, for this class, the difference quotient is just sort of a subset where it's more or less an aside, but it also deals with finding the value of a function. So we're going to find the value of a function by putting in an expression in place of x. So instead of using x, I'm going to use x plus h. So I would do whatever my function is doing to x, I'm going to do it to x plus h and see what that looks like. and then subtract the original function out of it, and then divide whatever's left over by h. Because the difference quotient, and we'll discuss this more when it comes up, looks like this. That's what the difference quotient is. It's a quotient. That means you did division. Division can be written as a fraction. Because a fraction is division and division is a fraction. All right, next thing. What is the next thing? What's the domain and what's the, finding the domain of a function that is defined by an equation. And then form the sum, difference, product, and quotient of two functions. That's doing the algebra on two functions. What you're adding two functions. What does that look like? You're subtracting two functions. What does that look like? And do it appropriately. You add and subtract appropriately. Finding the product. That means you're going to multiply the two functions together, and you're going to multiply them appropriately. That sometimes you have to make sure you're using, like when you multiplied binomials together in high school algebras, and when you multiply two polynomials together, using the correct techniques to make sure all the multiplies happen correctly. Finding the quotient of two functions. A quotient means you use division, which means you had a fraction. So you have a fraction, you have your first function being divided by your second function. And then you look to see if you can factor the numerator and factor the denominator so you can reduce the fraction. And what I mean by that, if I have 12 divided by 15, well, I can write this as 3 times 4 divided by 3 times 5. So I factored the 12 and I factored the 15. So I have like factors that go to 1, because this is 3 divided by 3, which is 1. So I get 4 over 5. So that's what we're going to be doing here with this. We're going to end up with something that we can possibly factor and reduce. And we'll get to that more closely, more into that later. So the first thing we're going to talk about, what is a function? I mean, what is a relation? A relation, simply put, is a set of ordered pairs. Okay, a set of ordered pairs where you have two sets of things, and that's what they say here. A relation is correspondence between two sets. A set X called the domain and a set Y called the range. A relation is each element of the domain corresponds to at least one element of the range. That means if I put them in as pairs, I have something from the domain and something from the range. Whether it be a set of numbers with a set of numbers, it'd be the name of states with the name of cities, or one of the examples they give is the year versus the price per gallon of gas. So, and it's called an ordered pair because the domain always comes in first and the range comes in second. And so this is one way of representing the relations, is by writing out all the ordered pairs or putting it in a table, writing it as ordered pairs, or putting it in a table where here I have the domain and here I have the range, and then I have just them all listed in pairs this way. This domain value goes to this range value, or this X value goes to this Y value. So the domain is the X's and the range is the Y. Now, this model here that they show is more appropriate for, what do you call it? A function with functions. Because you put a number in, that's the domain. The domains are the numbers you put into the machine, and the numbers you get out of it are the Y values, the range. Now, sometimes with a relation, the same number, like if I put 3 in, I get a -2, or I can put 3 in, I get a +9. Sometimes 3 gives us more than one number. Okay, with a relation that can happen. It is often helpful to think of the X as the input and the Y as the output. A relation could be expressed verbally. That's, you tell what's going on, and you talk about how the things are related to each other. A relation could be expressed numerically. That's using ordered pairs. So you have a list of ordered pairs, or it's in a table. Okay. It can be expressed graphically. That's where you graph it on a graph. Okay. So you have something, you have the XY plane, and you have dots on here that show the points that are the ordered pairs for that particular relation. A relation can be represented as a mapping. So if here I have my X values, here I have my Y values, and my domain is 3, -2, 7, 9, and 4, and my range is 2, 3, 9, -6, and 24, and 3. I already have a 3, so I'll make it 13. I like 13. Okay, so 3 goes to there, and 3 goes to there, and -2 goes there, and 7 goes there, and 9 goes there, and 4 goes there. The arrows show the pairings. Please notice 3 goes to 2 different numbers. 3 goes to 2, and 3 goes to 9. So this shows the pairing. So I can write this as a set of ordered pairs, or I can write it verbally saying that 3 is paired with 2, and 3 is also paired with 9, and -2, 3 from the domain is paired with 2 in the range. And then I could go through and describe each pair that way. Or I could graph this. And so we would have 3 with 2 and 3 with 9, and we'd have -2 with 3 and 7 with -6 and 4 with 13. So I would graph those points this way. So there's is shown graphically. I don't have it set up numerically, but I do have the mapping. Okay. So here's a relation where the average retail price has changed over the years. So that's the setup telling you we're dealing with years and gas prices. So in 2010, the average gas price was $2.78. So here it is describing it verbally. And now they're going to describe it. All right, so the domain and range of the situation is that the domain is the number, is the year. So 2010, 2012, 2014, 2016, 2018, and the range is gas prices. Okay, set of ordered pairs, well, 2010, 278, 2012, 362, on down the line. All right, as a mapping. So in the X, I would have the years, and in the Y, I'd have the gas prices, and they list them chronologically, not in the order that they showed up. And we'll see that. And then express it a graph. So they had a graph that was just the first quadrant graph like this that showed those. So the years was down here, and the cost was over here. So they did it that way. So we'll show that. So the domain is the years, and the range is the gas prices. The ordered pairs, well, 2010 with 278, 12 with 362, 2014 with 336, 2016 with 214, and like that. And here's the using a mapping. Notice they listed these things in order, least to greatest, and then showed the arrows showing us that 2010 went to 278, 2012 went to 362, and on like that, all the way down. And then with a graph, they just plotted them. Okay, so we have the 4 different ways of describing a relation, which means we have 4 different ways of describing a function. Verbally, which is saying word for word what's happening inside the function or relation. Showing the ordered pairs, graph as a set of ordered pairs, if possible. Showing the mapping of the ordered pairs, or graphing the relation or function. Graphing is the most common way of looking at functions, because most functions aren't discrete. This is a discrete relation because there's you can see all the points. So I can see all the points. If it was like a line, you can't see all the points because there's an infinite number of points on a line. So each one of these points on here, and it goes that way forever and down this way forever, and in between 2 points there's another point. And so this is a continuous where this is discrete, because there's no line connecting those points. There's between the points, there's nothing to look at. So, okay, now a function. Their definition of a function is a little wordy, and, but I'm going to write my definition up here. And it pretty much echoes what they say there. A function is a relation. In other words, a function is a set of ordered pairs where, oh, I didn't mention this before. I have horrible handwriting, if you haven't noticed already. So if you can't read what I've written for whatever reason, please let me know. I should have said this early on. Because if you can't read it, then you can't write it. You can't, and it causes a gap. So I don't want that. So please let me know and I'll rewrite it. All right, a function is a relation where the wording here is important. Because in English, each word means specific things. We use an imprecise language to describe things precisely. English is a compiled language. That means its source language is everywhere. That's why we have these bizarro spelling of words and rules of spelling that aren't set in concrete, because there's exceptions to every rule, because English is a hodgepodge of other languages. So some of the spellings carried over without the rules of why it's spelled that way or pronounced that way. Who decided that the GH was silent here, but pronounced like an F there? Through and laugh. Or though and laugh. Or even thought. With thought, it's not even, it's anyway. Don't get me on it. Okay. Where each X value, each member of the domain. So instead of saying each member of the domain, I say each X value, which is the first thing in the ordered pair, is paired with their wording here is associated with or associates with exactly, this is an important word, exactly one Y value. That means an X value cannot go to more than one Y value. Each X value is only paired with one Y value. So this example here, would this be an example of a function? And if more of y'all, I could see heads nodding or shaking. What did you say?
No,
Why not? How does this not fit that description, that definition?
because the 3 has 2 Y values.
3 has 2 Y values. What if I had this? What if I had 3, -2, 7, 9 over here? And then I had 3 seems to be my favorite number, because my go-to number when people tell me write down a number or pick a number, it's always going to be 3. So what if I had this situation? Is this a function?
Yes,
Why?
because all the X values only have 1 Y value that corresponds to them.
Yeah, but I have 2 numbers going to the same Y value. How is that still a function?
Because the X values only have 1 Y value.
Thank you. That's exactly right. It doesn't matter that a number in the range is used multiple times. What matters is the X values used only once. So like over here, all the Y values are only used exactly once, but the X values, we had one X value that was used twice. So that made it not a function. That's why the line x equals 2 is not a function, because every point on that line has the exact same x value. They all have different y values, but they have the same x value. That's why a horizontal line, y equals a -3, that's why this is a function, because all the x values are different. The y values are all the same. That's okay. That's okay. Because what that's telling me is that this x value only goes to one y value. This x value only goes to one y value. They all go to one y value, but they're all the same y value, that's fine. But -7 only goes to -3. It doesn't go to another y value. Okay. And the sets x and y will usually be sets of real numbers, in which case it's a real function. Two sets can also use complex numbers. Then it's defined as a complex function. We get a little bit, a tiny little bit into complex numbers, but not too deeply. That's a course called complex variables, which I did not do so well in because I didn't have my group with me. I made a C in that class. And then when I took differential equations, my group hadn't taken the complex variables. So when we did differential equations, they were kind of in the dark of about a lot of the stuff he was talking about, but I understood it completely because I had the complex variables. So I did a little bit better in differential equations 1 than most of the group did. Anyway, so I didn't tell this to my other class. You will have a question on the first exam and possibly all of the exams. That's the exact same question. And that question is, what is a function? What is a function? I think this is the simplest definition to memorize and to write it down verbatim. Or you can memorize their definition and write it down verbatim. Or you can find another definition and write it down verbatim and memorize it, and you just write it down. That's how important I feel this definition is. What is a function? Well, a function is a relation where each x value is paired with exactly one y value. It's an important concept in mathematics, and it's a building block for calculus. And a lot of things that we deal with is strictly functions. There are some things we deal with that aren't functions. But if you're dealing with a function, this is very helpful to know, and very so you're trying to prove something, and so, but my x value, this x value gives me two different y values. So then something's wrong with my function because it's not a function. So I have to go back and find out what's going on there. So if you're doing something with in engineering or something like that, this is what you need to be aware of. Okay. So the x is the domain and the y is the range. The x goes into the domain. I mean, the x goes into the range. And that's called, they talk about that the y is the image of x. because the function, the value of the function is the image of x. Because x gives us a specific y value. And so that y value is the image of x on the range. It's an interesting concept. They talk about the set of all images of the elements in the domain is called the range of the function. So notice that they have two data points out here that are in the range, but they're not in the image. So that means that this range here is a subset, a proper subset of the set Y. And that's the next thing they talk about here. All right, a proper subset means that everything in the set, like everything in the range, comes from the set Y, but not everything in Y is in the range. So I have a set A, and I'm going to define the set A as containing the numbers 1, 2, and 3. Whenever you see something listed inside a set of braces, it's a set. If I had this listed inside parentheses, then that's a three-dimensional point in space. X, Y, Z. So we're dealing with where this is X and this is Y and this is Z. So I go 1 unit this way, 2 units this way, and 3 units this way. So that's this point in space. Yeah, it's kind of hard to see on a two-dimensional representation of a three-dimensional space. But I had a TI, well, I still have it. It's messed up. A TI calculator called the Voyage 200 that would graph 3D objects. So you could actually do a three-dimensional function. Back to this. And now I have a second set. I'm going to call it set B, which contains the numbers 1 and 2. Now, B is contained in set A. Everything in B is in A. But B does not equal A. That means everything in B, everything in A is not in B. So that makes B a proper subset of A. If I just said that B was a subset of A, that means B could contain the number 1, could contain the number 2, could contain the number 3, could contain the numbers 1, 2, 2, 3, 1, 3, or the numbers 1, 2, and 3. So B could be the same as A if it was just a subset. But since I said it's proper subset, that means it will contain fewer items than A. And in this case, it's 1 fewer. That's your introduction to set theory, which is about as far as I go. I love set theory. It's a lot of fun. I used to teach it in a class I taught at Fort Sam. And most of my students absolutely hated it. So anyway. You got confusing. Now, relation, if you're given a mapping, is it a function? So is letter A a function? Yes or no?
Wait, what?
All right. Here
What
we
was
have
it?
here, letter A, we have a relation between the menu item and the price. Is this relation a function? Yeah, I see a head nodding. Everyone concur.
Yes.
Yeah. Because it is, because the beef taco only has one price, the chicken taco only has one price, the shrimp taco has only one price, even though they all have the same price. It's just the beef taco only has one, chicken only has one, and on down the line. So, yeah, so it's a function. And the domain, what's the domain?
Menu.
Menu items. So beef taco, chicken taco, shrimp taco, quesadilla, nacho. And the range,
Price.
the price. Please notice, just like in the mapping, they only listed the 250 once because they want to know what was there, not how many times it showed up. Even though in a menu, they might show this price the 3 separate times. I've noticed that menus run one of 2 ways. It's either a direct mapping like this is, where they have the price of the items, so they group them by the price, or it's more like an ordered pair, like they're showing the ordered pairs, but in a table, where the beef taco has its own price, the chicken taco has its own price, and the shrimp taco has its own price listed, even though they're all the same. Okay. And it is a function because the domain doesn't repeat, doesn't have more than one price item. Is this a function? Yes or no? That's the main thing I'm concerned about. Yeah, I see one head shake nodding.
Yes.
And yeah, the names are the domain, and the number of steps is the range. Is this a function? The correspondence between students graduating from high school and the colleges that these students are admitted into. Is it a function? I saw a tentative head shake. Oh, I see a thumbs down. So no. Why not? Does Aaron have 2? Yeah, because Aaron has been accepted into 2 colleges. So that the double arrows, the 2 arrows coming up of Aaron, make it not a function. The domain is still the student name, and the college is still the college name. The range is still the college name, but it's not a function, because a relation does have a domain and a range, just like a function does, because a function is a range, is a relation. Is this a function? This set of ordered pairs. Yes. Is this a function? Yes. Is this letter C a function? Yeah, I'm kind of rushing through these because we're at time. Yeah, why isn't it a function? Someone tell me quick. Yeah. The -5 has two y values. -5 goes to 1 and -5 goes to -3, so that makes it not a function. All right, and we'll start it with this slide next time. We didn't get as far as I thought we would, but we're only 3 slides from where I wanted to be. So we'll start with this next time. And let me be greedy and stop sharing. Okay. If y'all have questions for me, do not hesitate to send me emails. Once I get the discussion room up, put comments in there. So I'll see you on Wednesday. And hopefully I have more of my shit together than I do today. So, bye. Everything's going bye-bye.